Standard form of a linear equation. Good, Antonio. Thank you. AX plus BY equals C. Okay, and when we're modeling with standard form, the idea that we're going to try and grasp here is that in order to do this, we need C will kind of be our total desired. So C will be our total desired value. And our total desired value is made up of two things. So we'll say that this is part plus part. Okay, so maybe we'll be selling two things. And we can say the part value for both of these. So if we're selling something, the total amount of money we make, let's say we're selling hot dogs and hamburgers, the total amount of money we make is the amount we make from hot dogs and the amount we make from hamburgers. Okay, so let's pick up on the example we left off with on Monday. I know it's been a crazy long time, but let's pick up right where we left off and just do a little bit of a walkthrough of this stuff. All right. So we were talking about selling calculators. We had scientific calculators for $35, and then we had graphing calculators for $80. Those graphing calculators are expensive. And we wanted to raise $1,120. We broke down the information by analyzing it, making a plan, and writing an equation. So we can see that our part total in standard form was the amount we made from scientific calculators. That's the 35S, $35 for each scientific calculator, and $80 for each graphing calculator. This page asks us to create three or calculate three values for scientific and graphing calculators. What that means is I'm going to pick numbers here. So let's say that the first number I want to see is how much money if I only sold graphing calculators. So if I sold 0 scientific calculators, how many graphing calculators would I have to sell? That's my first question. What happens then if I sold 0 graphing calculators, if everybody wanted a graphing calculator? And then the last point that we're going to find here comes from the question. And it says, approximate the number of graphing calculators that need to be sold if 16 scientific calculators are sold. So the last point we're going to look for is the value where 16 scientific calculators are sold. Well, how do I find the number of graphing calculators that I have to sell if I don't sell any scientific calculators? Well, let's jump over into some scrap paper here, and let's look at our equation. So I'm looking for the point 0 comma something, and my equation is 35 scientific calculators, $35 for scientific calculators, plus $80 for graphing calculators, and I want that to be equal to 1,120. Well, one way we can think about this is that these ordered pairs is going to be our S and G. Okay, so our scientific and graphing calculators. I have 0 S, that means I'm plugging in 0 for S. So this will be 35 times 0. Plus 80G equals 1,120. Well, this problem's not that hard then. We see that 35 times 0 is 0. So we get 80G is equal to 1,120. Can somebody tell me how I get G by itself here? I want to get rid of this 80. How do I remove this 80? Good, thank you, Antonio. I'm going to divide by 80. It gives me G, and I did this in the calculator, so I'm going to cheat and say that G is 14. So my point here is 0, 14. So I go back to my sheet and say that the number of graphing calculators I have to sell if I sell 0 scientific is 14. Well, now, what if I sell 0 graphing? We can do the same thing, except now we're going to say, well, how many scientific do I have to sell if I sell 0 graphing? So instead of plugging in 0 for S now, we're plugging in 0 for G. So if we do that, we have this 35S plus 80G equals 1,120. But this becomes 0, plugging in 0 for G. $1,120, 0 times 80, and then I still have this 35S. Well, I have to solve for S here. This is 35S is equal to 1,120. Just like we solved for G, I just have to divide by 35. This will give me that S is equal to 32. So 32, 0 is my second point. So I go back into my table here, and the number of scientific calculators I have to sell if I sell 0 graphing is 32. Well, we've got one more point to find, and then we can start graphing these. And that is, what happens if I sell 16 scientific? Where would I have to plug in this 16? What can I do with this 16? Is that going to be my S or my G? 16, is that my S or G? S comma G. And it's saying that I'm selling 16 scientific. So that's going to be my S. I want to find out the G. So all I need to do is plug in 16 for S. So 35 times 16 plus 80G, 1,120. Well, now we just have to simplify and solve again. just solving equations. So this is 35 times 16. That's 560. How do I solve for G? Let's get some answers going in the chat box here. Let's try and get you guys going here this morning. How do I solve for G? I'm going to get G by itself. Good, I want to use my inverse operations. Okay, so I can create a table here if we want. We can use those inverse operations tables. Here's what I'm doing to G. Here's the inverse operations of them. The first thing that we see we did to G, if I start at G, is I multiplied it by 80. Multiplying by 80, and then I added 560. I want to start at the bottom and work my way back up. What's the opposite of adding 560? Good, thank you, Jay. I want to subtract. Takeaway or subtract, thank you. Subtract 560. And the opposite of multiplying? Dividing. Good. So this is divide by 80. So the first thing we'll do here is I'll draw my river. We'll subtract 560 from both sides. That'll get us to 80G equals, well, I know that this is actually half of this, so this is 560. And then, so we did our subtraction, now we have to divide by 80 again. So G is equal to, this looks like it's going to be 7. So how many graphing calculators do I need to sell if I sell 16 scientific? So let's write that here. If I sell 16 scientific calculators, I need to sell 7 graphing calculators. So we go back to our little table here. See if I can get it in there. If I sell 16 scientific, I need to sell 7 graphing. Well, we can graph this equation here, and the reason we picked 0 twice is so the graph is easier to find. Let's take a look at this graph real quick. Now I just want to plot the points on this graph. 0, 14, 0, 14. This looks like it goes by 5s, 5, 10, 15. So 14 is going to be right here. At 0, 14. And then 32, 0. 32, 0 This goes by tens, 10, 20, 30, 32 should be right here. I've got 2 points so I can connect the line. And then if I looked for 16, 16 might be right here. We could see that this value, this is 16, this would have to be 7. And we can answer the last question here. For 16 scientific calculators, 7 graphing calculators must be sold. And that is all we would need to do for this problem. So in this problem, it tells us a school store sells binders for $5. That seems important to me. So I'm going to say it sells binders for $5. I'm analyzing the information. This is our first step. And notebooks for $4. The store needs to sell $80 worth. That looks important. They need to sell $80 worth. That looks like it's going to be my total. I want to write a linear equation. So we're writing a linear equation, graphing the linear equation, and then we'll use the graph to approximate the number of notebooks. So I'm looking for the number of notebooks. The store must sell if 12 binders are sold. So lots of important pieces here. So one more time, we'll read it out. A school store sells binders for $5 and notebooks for $4. The store needs to sell $80 worth of these two items. Write a linear equation that describes the problem and then graph the linear equation, making sure to label both axes with appropriate titles. Use the graph to approximate the number of notebooks that must be sold if 12 binders are sold. So let's think about the equation we need to set up. They give us a whole bunch of our important information, the red information that we analyzed here. That's what's given to us. Remember, when we're writing in standard form, this looks like we have a part. I'll say part will be a total. So the money we make is our total. They need to sell $80 worth. Okay, so this is the money we make. What are the two parts that we make money from? What is one of the two things that we're selling to make money from? Well, I'm trying to make money. Okay. I'm trying to make money by selling binders and notebooks. I sell binders for $5 and notebooks for $4. So the first part we can say is our binders, the money we make from binders. The second part is the money we make from notebooks. If we add those two together, it'll give us the money we made. So our next step will be to make a plan. We can say that the number of binders we sell is B. So if I sell a binder for $5, the amount of money I make from a binder, for one binder, I make $5. So for each binder, it's $5. That for each is like our multiplied here. And we can say the same thing for the notebooks, but notebooks only cost $4. So our binders plus our notebooks will be equal to the total. But we want to make $80. So our equation they have written here, again, it's our binders plus our notebooks is our total. 5b plus 4n equals 80. They calculated three sets of values here. Again, they chose 0 for two of them. And then why did they pick 12? Well, they picked 12 because that's what the question is going to be asking us for. For the graph, they labeled their axes now. Okay, so if this is a regular table, we would say that this is our X and Y columns. So on our X-axis, we want binders. So on our X-axis, we have binders. Our Y-axis would be notebooks. So on our Y-axis, we have notebooks. And then we just graph the points. 0, 20, 0, 20, 16, 0, 16, 0, and 12, 5. And then we can use the graph to answer the questions. Okay, so let's look at this graph real quick. What does this point represent? What's happening at this point? Well, at this point, how many binders did I sell? Good, thank you, Antonio. So this point represents the number of notebooks we sell, which was 20. So 0 binders and 20 notebooks. If I sell 0 binders, if we sell 0 binders, I have to sell 20 notebooks. Cool. That's all it's looking for here. How would this change? Well, now we're saying that I have, instead of 0, 20, I have 16, 0. We can use the same phrasing if we sell how many binders? How many binders did we sell at this point? Good, thank you, Drew. If we sell 16 binders, do I have to sell any notebooks? Zero notebooks. Remember, this is the binders in the notebooks. So our X and Y. All right, and this is the question that they asked us to really answer. What is the approximate number of notebooks that need to be sold if 12 binders are sold? So let's look at this graph one more time. I'm selling 12 binders. So I'll go to my axis, my binders axis, and I want to see where they sold 12. Well, right here is where they sell 12. How many notebooks do I have to sell? Well, this line gives me what I need. So I go up from 12 binders until I hit the line. And then I can look at that from my y-axis, and how many notebooks would this be? How many notebooks would we have to sell? Good, Antonio. Thank you. Yeah, we have to sell 5. And again, we see that we already calculated this right here from our equation. So we would sell 5 notebooks. All right, I think we're only going to do one more problem today, and we'll just we'll keep spreading this out some. But let's do one more example where we work all the way through it, and then we'll call it a day today, and you can actually here. Let's touch up our notes real quick so we have some things to look at for the Khan Academy and IXL. All right, let's do quick notes here. Say modeling with slope intercept. What is slope intercept form? Thank you. Good. Our slope intercept form is y equals mx plus b. I suppose we're using uppercase B here for today. And what we want to think about for modeling is that this m, say our m here, is our rate. Okay, this is how much we're charging. It's the amount that changes. So this will be in like per hour. Those are some key words that we're looking for. Our B value will be our initial amount, and sometimes we'll see it phrased as a flat fee or a one-time fee. Okay. So we'll have a one-time fee. So if I say that a trucking company charges say they charge $200 for the pickup, pickup truck, and then they charge $60 per hour. Maybe this is like a moving truck. That would be an expensive rental. Let's say $60 per day. $60 per day. That would be better. If I wanted to write an equation for this, I could say that my cost is my y. So y is equal to our rate here is $60 per day. So that'll be 60x. And then they charge $200. So that's a flat fee. That's a one-time thing. They only do that once. So I just add 200. So slope intercept form is going to be a little bit easier for us. We just have to identify the pieces. But then we also want to identify what they represent. Our y is our cost in this case. And it's the cost for the number of days. All right, that'll help us with our Khan Academy and IXL assignments. But let's do one example with standard form all the way through again. All right, here we go. We're going to look at this second example here, number 2. You don't have to write these in your notes, but please make sure you're paying attention. So again, we're going for standard form here. I want AX plus BY equals C. Maybe we'll put that here. AX plus BY equals C. I want to write a linear equation that describes the problem. So let's understand what's happening here. We're going bowling. A bowling alley charges $2 per game. And we'll rent a pair of shoes for $1 for any number of games. So how many times will we pay this $1? And actually, I don't think I like this problem. Let's try this. Let's do a different problem here. Let's do number 3 instead. I like number 3 better. Okay, let's do number 3 here. So this is a wheelchair basketball league. And they're playing a benefit game to meet a fundraising goal of $900. So we have a goal of $900. Tickets are $15 and snacks are $6. So if we have a total goal of 900, remember the part. All right, Chase, thanks for letting me know, buddy. Good luck with physical therapy. So again, in our problem here, we're looking for a total goal. Well, our total goal is 900. It came right from the problem. The first part, how we raise this money, is by selling tickets. So each ticket is $15. So I'm going to write that ticket, that $15 ticket. For each ticket, it's $15. So maybe we'll say 15. And we can either use X or T for tickets. Let's use T for tickets. And then the other part is how much I sell or make off of snacks. That's 6S. So our equation that we're going to be using is 15T plus 6S equals 90. Well, if I want to graph this equation, I'm going to plug in 0 for both of these. Okay. So we'll plug in 0 for T. That will give me 0 comma something. And then we'll plug in 0 for S. And that will give me something comma 0. X and T, Y and S match up. Okay. So let's do this real quick. This will take us just a minute here. This is like example 3 here. So we start with this equation, 15T plus 6S equals 900. And let's have a couple people start both sides of this. So let's have a couple people plug in S as I plug in T. I'm going to say that t is 0. So that's 15 times 0 plus 6s equals 900. That means 6s equals 900. I divide by 6, and s would be 150. So I can see that s is 150. Then I plug in 0 for s. Let's see if anybody got 0 for s here. You can check your work with mine. So again, we're at 15t plus 6s equals 900. Now I'm plugging in 0 for s. So 15t plus 6 times 0 is 900. Well, that leaves me with 15t is equal to 900. We divide by 15. And t is equal to 60. I know I'm kind of flying through this math, but I'm recording this so you can watch the video later if you need to. So t is 60. All right, so let's graph the line. And this is the last question. So I plot the points 0, 150, so 0, 150. Looks like these go by 20s, 20, 40, 60, 80, yep. So 0, 150 is going to be right here for me. Right in between 140 and 160. And then 60, 0, well, this goes by 20s as well, 20, 40, 60 is right here. I can graph the line between those 2 points. And we'll use this line. The last question we need to answer here, if the team sells 50 tickets, how many snacks does it need to sell to reach the goal? So I go to tickets here. I want to sell 50 tickets. So I'm looking for the point on the line that has an x value of 50. Well, 50 would be right about here. It looks like, touches our line right here. And that point in snacks looks like it's right about here. What number might you guess if this is 20 here? How many snacks might we need to sell? Well, to me, based on this graph, the graph looks like it's maybe about 30. But do we know for sure? Maybe my line's a little bit off. Maybe it's not perfect. And these numbers are too big to tell. So if I sell 50 tickets, another way I could do this is plug in 50. And that's for t. So the last part of this problem here is we're going to check whether our approximation is close. We say we have 15t plus 6s equals 900. And now we're plugging in 50 for t. We'll go through the math here. 50 times 15 is 750. Still equal to 900. And then we solve for s. Minus 750. If I do it to one side, do it to the other. Six s is going to be 150. And then I divide by 6. And we get s is 25. So using the graph, we said it was approximately 30. 30 works, but the real number is 25 snacks. All right, and we found that by plugging it in. And ladies and gentlemen, that is far enough math.